They called it the alien's language, a mathematical theory so perplexing it left even the brightest minds in a state of bewilderment. For years it stood as an enigma until now. The inter-universal Teichmuller theory, or IUT, isn't just a complex mathematical framework. It's a potential key to unlocking some of the most profound mysteries in number theory. Proposed by Shinichi Mochizuki, this theory aimed to solve the notorious ABC conjecture, a deceptively simple-sounding puzzle that hides unfathomable complexity. Yet its unconventional approach rendered it nearly indecipherable, leaving the mathematical community divided and intrigued. Despite widespread interest and effort, the theory remains largely impenetrable, even to expert mathematicians. Some openly admitted they could not understand its framework, while others argued over whether the proof even held. This uncertainty has kept the theory hovering in a strange liminal space, neither fully accepted nor rejected. It remains a question mark in a field built on logic and clarity. In the early 2000s, Shinichi Mochizuki, a reclusive and brilliant mathematician at Kyoto University, unveiled IUT in a sprawling series of papers published in 2012. Unlike conventional proofs that build upon familiar mathematical tools, IUT introduced entirely new structures and even invented its own vocabulary. Terms like alien arithmetic, holomorphic structures, and Frobenius categories became symbols of both intrigue and confusion. The theory claimed to prove the ABC conjecture, a problem so central that many believe solving it could lead to a domino effect in other areas of mathematics. The ABC conjecture itself revolves around the fundamental relationships between prime numbers and addition. While that may sound simple, the conjecture cuts to the very foundations of number theory, linking together vast branches of mathematics in ways that are still being unraveled. Yet despite existing for over a decade, IUT has not been fully verified by peer review because it is so difficult to understand. Even seasoned mathematicians with decades of experience have struggled to follow its intricate logic. Some who attempted to learn IUT spent years on it without ever reaching the core of the argument. Conferences were held, papers were published in response, and debates filled academic halls, but clarity remained elusive. A special issue of the publications of the Research Institute for Mathematical Sciences was even dedicated to it, but it failed to deliver consensus. For some, the difficulty of the theory itself seemed to imply its validity. How could something so intricate and internally consistent not be true? For others, the lack of transparency raised red flags. Peer review stalled not because of overt flaws, but because few could follow the full path of reasoning. And so IUT drifted, misunderstood, monumental and unresolved. Enter Zhou Zhongpeng. A 28-year-old software engineer in China, Zhou had once pursued a PhD in graph theory before leaving academia. But his passion for mathematics never faded. In 2023, driven by intellectual curiosity alone, Zhou decided to tackle the most daunting mathematical theory of the modern age. Over 5 relentless months, he immersed himself in the dense forest of Mochizuki's writings. Armed with tenacity and fresh perspective, Zhou began identifying patterns others had missed. He wrote and shared a new paper exploring applications of IUT, focusing on how to extend its logic to other unresolved mathematical puzzles. He reached out to Mochizuki and Fisenko directly, something few outsiders would dare attempt. What followed would surprise everyone. Zhou's work stunned those who took the time to read it. Ivan Fisenko, a leading mathematician at the University of Nottingham and one of the few experts who had studied IUT in detail, was so impressed that he invited Zhou to collaborate further at Westlake University in Hangzhou. Fisenko described Zhou's work as an important new development, praising his ability to simplify aspects of IUT that had previously appeared hopelessly convoluted. Zhou's paper offered a new way to generalize Fermat's last theorem, extending the logic to infinite families of equations in ways that Wiles's original proof from 1995 could not. His innovation didn't just reiterate Mochizuki's original points, it built upon them in new directions. He identified potential flaws and proposed refinements, making the entire theory slightly more navigable. For example, Joe introduced novel diagrams and notational tools to bridge gaps between abstract ideas and more conventional mathematics, creating a conceptual map of the theory. In doing so, he didn't alter the original framework, but helped others visualize it, an essential step toward understanding. He also drew connections to modern cryptography and algebraic structures that had been previously unexplored in IUT's original context. Notably, Joe proposed that some of IUT's more arcane sections could be clarified using known methods from homotopy theory and category theory, tools already familiar to parts of the mathematical community but not previously applied to IUT. His ability to blend these frameworks showcased not just technical skill, but deep conceptual insight. One of the most remarkable aspects of Joe's story is that he is not affiliated with any academic institution. His research was conducted in relative isolation, without institutional support or funding, using only publicly available materials and digital tools. It's a powerful reminder that some of the most transformative ideas in science and mathematics may come from outside the traditional halls of academia. Zhu, however, remains humble. In a post on Jihu, a Chinese platform similar to Quora, he wrote, "Those papers are based on the research of predecessors. My work has only made some minor innovations and explorations, and I hope to contribute a modest amount to the relevant field." But many believe his contributions are far more than modest. They represent a turning point in our approach to the most abstract mathematics. If interuniversal Teichmüller theory can be better understood, or even partially verified, it could trigger a renaissance in number theory and algebraic geometry. At its core, IUT presents a radically new way of comparing mathematical objects, not by direct transformation, but through a kind of metaphorical translation across universes of logic. This idea, though hard to visualize, may mirror techniques in quantum computing, where entangled systems must be understood holistically. Cryptographers are also watching closely. The fundamental ideas in IUT involve deeply hidden structures of arithmetic, the very same that underlie encryption protocols used around the world. Some speculate that if IUT's logic can be translated into algorithms, it could reshape how we secure data and transmit information, perhaps even impacting blockchain technologies or post-quantum encryption. Still, one of the greatest challenges lies in accessibility. As long as IUT remains understood by only a small handful of individuals, its potential remains unrealized. The hope is that contributions like Joe's and others who follow can gradually open this world to a wider community of scholars. Already, younger mathematicians are expressing renewed interest. Online forums and discussion groups are springing up around IUT, with Joe's name frequently cited as proof that new perspectives can breathe life into even the most arcane areas of math. Slowly but surely, the alien's language is becoming something closer to human speech. If that process continues, we may look back at this decade not as the age of confusion around IUT, but as the moment it finally began to speak. And the translator, a software engineer who simply couldn't let the mystery rest. The story of Zhou Zhongpeng and interuniversal Teichmüller theory is more than a tale of numbers. It's a story of curiosity triumphing over complexity. It shows that sometimes the future of science doesn't depend on massive laboratories or billion-dollar grants, but on one person refusing to give up on a mystery. So where does this lead us next? Could other impossible theories be waiting for their own Joe to come along? Subscribe to this channel for more real, recent science news that pushes boundaries, breaks conventions, and sparks the imagination. Because the next big breakthrough might already be out there, just waiting for someone to understand the language.